to recap balik because ada some of you still lagi mungkin tak berapa faham pasal how to draw the equivalent circuit for this example. Agak sukar nak explain dalam WhatsApp because this is drawing. I tak boleh nak, kalau calculation tu senang kalau drawing ni you kena faham lah. Kita start, kita tengok pada contoh question yang ada kat sini. So ini semua tak perlulah, yang atas ni ada explain before this, so I think no need to explain one more time. Contoh example 3, fault kat sini fault occur at this bus 3. So what happen is current you akan ada current flow. Saya nampak kat you mungkin I buat macam ni senang bagi faham sekejap wait mungkin I boleh buat macam ni. Mana ni dia punya sekejap search pin alright. I share balik the screen. Alright, screen hide this one ini tak perlu. This one so let's say fault kat sini fault kat sini. Silap. Fault kat situ. What happen is current akan flow ke sini betul so sebenarnya kalau kita kata look at from the fault location, apa yang kita kena buat sebenarnya so you biasanya you akan draw macam ni lah, satu common base. Tak cantik lah draw, tak apalah, abaikan satu fault macam tu I fault alright. So when fault occur here, so current dia akan divide by 2 divide into 2. So you basically you boleh imagine lah dia akan ada dua parallel line saya tak lukis lagi impedance dia akan dua parallel line. Sebab current ni dia pecah dua so the first line ni, let's say you are sebab kita look at the fault location so you kan ada line 1, you kan ada T1 and you kan ada G1 so you draw kat sini start from N1, T1 and G1. Untuk side ni pula, right side you ada T2 and motor load so kat sini ada T2 and motor. So this is the equivalent circuit. Simple kan? Jadi you kena faham tu lah how to the sketch sama dengan ini kan. Konsep yang sama ni punya example. Look at this one. Yang lain tu how to find the Z thevenin tu you faham sendiri lah. Tapi the first step you nak tahu and then satu lagi untuk determine the fault, make sure the voltage is 1 this is assumption voltage 1 per unit. Faham lah memang tak diberi kalau case ni pula sama juga. For this case you akan ada ini you ada dalam bentuk parallel. Yang tadi series ini ialah series series network. Ini kita panggil parallel network Biasa dalam exam soalan macam ni akan keluar dia tak akan bagi series. Series tu simple. Dia akan bagi susah lah dalam bentuk ataupun ring bus ataupun parallel bus Tapi konsep yang sama Alright. So what happened is when the fault occur here kat sini, tak kisahlah kat sini ke, sama saja right? Okay, let's say fault at bus 5, konsep yang sama, you kena draw satu common bus. Okay, okay dalam tak apa, kita buat benda yang simple lah. Okay, ini fault Okay, what happen is dia akan divide by 2, sama juga dia akan ada divide by 2. Okay, contoh yang ambil T3 G3 so dia akan ada T3. Okay, kat sini ada T3, dia akan ada G3, sama. Okay, alright. And then dia akan terus sambung kepada ni. Sebab ini current dia ke sini kita look into here kat sini, dia ke sini, dia akan terus direct connected pada source kat sini lah. Okay. Okay, tengok kat sini Inilah dia T3 G direct sama pada common bus. Okay, tapi at bus 1 ni dia akan right, komponen dekat bus 1, ini bus 1 ni lepas pada bus 1 dia bersama pada bus 1, tapi bus 1 dia ada T1 line 1 to T2 and connected to bus number 4. So dia akan ada satu bus number 4 in the middle between common bus dengan bus 1. Tapi inilah element atau component between bus 4 and bus 1. This component not directly connected pada common bus. Kalau you tengok sini pun dia tak direct, dia tak bersambung direct pada sini. Tidak dia bersambung between bus 1 and bus 4. So that's why kat sini ialah bus 1 and bus 4. And then kat sini ada motor. Okay, motor ni lah yang akan sambung pada common source tadi lah. Ini motor. And dia parallel juga dengan load. Sebab dia parallel dengan load 1, 2. Okay. Kalau you tengok. And then this side, right side pula. Dia ada line 2, T4 connected to bus 4. So kat sini you tengok. Okay. Kat sini line 2, T4 connected with bus 4. And dia akan connected with these two motor and load. Motor and load, so T4. So itu cara we draw the equivalent circuit. Sama juga untuk question number. Ini semua ni you belajar sendiri lah. Ini how to simplify. You belajar circuit dulu kan. Ingat ini ialah delta to star transformation. This is the equation yang kita guna. Ada juga circuit nanti you have to not from delta to star, star to delta pada. So this is the star to delta. So you dah belajar circuit sebelum ni. So I hope you clear macam mana you nak dapatkan Thevenin equivalent Z Thevenin lah. So I takkan ajar satu-satu lah because you dah ambil. You belajar sebelum ni kan dekat mana? Circuit analysis ni. Part berapa you belajar? Ada tak?
Ada belajar.
Kat mana? Part berapa sekarang? You part 4 kan? Mungkin part 3 or part 2 ataupun masa matric or diploma?
Diploma
You ajar circuit you dah belajar circuit tu. Itu you kena guna balik. Tak faham you buka balik buku-buku tu So I tak sempat nak cover everything So kita cakap tentang benda yang you dah tahu. I hope you ada idea apa yang I ceritakan kat sini Okay. Cuma isu dia nak dapatkan equivalent circuit Ada setengah orang tak berapa clear lagi. Tapi kalau you buat 2-3 kali insya-Allah you akan faham So sama juga case untuk example number 5 konsep yang sama So current pecah 2, 1, 2 So mesti ada parallel line. Tapi you kena faham lah dekat mana you nak sambung It will look like this circuit juga sebenarnya Dia tak straightforward Dia akan ada macam ni. Dia akan ada delta connection untuk you simplify into star Alright, untuk this question Okay. Ni soalan tutorial. Faham Boleh ke? You nampak tak macam mana nak buat draw kan? Faham Ataupun you perlu pergi exercise untuk case ni. Okay, kita tengok balik yang ini Ini I pernah tunjuk sebelum ni dalam kelas sebelum ni pasal fault This is line to line fault. Okay. Line to line fault maksudnya ada line, double line tu dia shorted together. Kita dah buat case ni Case ni okay. Jadi but ini asymmetrical fault. Yang tadi ialah symmetrical. Balance fault. This one is unbalanced fault. So you tahulah kalau unbalanced fault what happen is you kena change to the symmetrical component positive sequence, negative sequence and zero sequence. Okay, for the example is line to line fault. Bila kata line to line fault, what you need to do, you need to refer to this not single line, line to line yang ini. So ceritanya dia nak atau I4. So I4 basically last ini you kena dapatkan nilai IA dulu. You dapatkan nilai IA, positive sequence, and then this is the fault current. IB and then minus IC equivalent to imaginary minus ordinary square root of 3 IA. So ceritanya you have to get the value of IA1 atau positive sequence. Dia sama yang positive sequence sama in order to get the fault current. So untuk for this example, okay, kalau you tengok all the way dia punya calculation, at the end dia nak cari ialah nilai positive sequence referring to this equation in order to get the fault current. So apa atas ni? Mungkin I dah explain sebelum ni, I nak recap balik. So ceritanya you have to draw the positive sequence equivalent circuit. Ni konsep yang sama. Cuma kat sini dia letak common bus. You boleh juga letak kat atas konsep yang sama tak ada beza Okey, kita tengok balik nak bagi faham Kalau kes ni sama juga similar concept from the previous example. Okay, fault occur here, double line to line. So current ni dia akan pecah kepada looking at this point. Dia ada 3 kan? 1, 2, 3. Betul 1, 2, 3. Dapat kan? So dia akan ada 3 ni. 1, 2 dan ke 3. Faham Boleh ke? Faham kan?
Boleh.
Semua faham sebab kalau dalam kelas senang face to face I boleh draw untuk you, tapi dalam online you tahulah, so you kena boleh imagine the thing Okay, so for example, because fault occur here, you boleh imagine fault current dia daripada sini dimasuk ke sini, daripada sini current akan flow. Current bukan flow daripada fault current ke sini balik, tapi kita nak draw equivalent circuit. Biasanya kita tengok daripada fault location basically current daripada ni, current ke source dia akan lalu ke sini ke fault, daripada sini ke fault, and daripada sini ke fault. So ada 3. So you must have 3 branch, 3 parallel line 1, 2, 3. Faham Okay, ambil the first one. First one is this one between T3 and G3. So dia kalau posisi sequence ni, ini apa? Ini star delta ini untuk zero sequence. I akan explain kemudian kita settle untuk positive sequence. So positive negative sequence dia tak relate. It doesn't effect on this star or delta connection. Ini untuk zero sequence. Okay. So maksudnya G3, T3 dia akan connected, join together. So you have here G3 dan T3 Okay. You boleh buka sendiri untuk you lari clear, sebab I takut slide ini small tak nampak kan. Tapi this is the concept. So daripada fault, current flow ke fault. So G3, T3. So you have G3, T3. So the second one is I think dia ambil yang ni kot rasanya example ni. So dia between bus 7, bus 5, bus 5, bus 2. So dia ada, sini ada line sini ada impedance. Ini kan transmission line, dia ada impedance. So impedance dia you can get from this, you can obtain from this table 1. For example, 7 to 5, 7 to 5, this one 7 to 5. Okay, 7, 5 to 7, samalah case ni ini Kenapa tak keluar dia punya ni marker? Okay, 7 to 5 Okay. Atau yang relate, tak apalah Okay, ataupun I boleh buat macam ni. Tadi kat sebelah nak scroll down, tak apa. I ingat you faham 7 to 5, so 7 to 5. So because the reactance, this is positive, negative, zero sequence. So because this is the equivalent circuit for positive, so you use this data yang ini. So X1 always represent the positive sequence. So that's why nilai dia 0.4. So kat sini lah 0. Line ni 0.4, 5 to 7 Kalau tengok betul, tengok this is J 0.4 per unit. And then dia ada line 2 to 5, 0.2. 2 to 5, 0.2 positive sequence. Kenapa? Because kat sini 2 to 5. And then dia connect. So dia connected with T1 and G1. Dia bersambung. Okay. And then in between line ni dia ada line between bus 2 and bus 4 dia join 2 to 6, 6 to 4. So you ambil the value of 2 to 6, 6 to 4. So you have here 2 to 6, 6 to 4. Dia bus 2 dengan bus 4. So at the bus 4, kita tengok sini balik 7 to 8, 8 to 9, 9 to 4. So ada 3 transmission 1, 2, 3 3 transmission impedance kat sini. So you buatlah 3 kat sini. 1, 2, 3. Join together. And then dia connected with T2 and G2. So dia connected with T2 and G2. Okay, itu equivalent circuit for positive sequence. Okay, faham Boleh Dia dapat dia idea macam mana nak draw? Dapat kan? Okay, faham kan? Okay, boleh kalau you boleh, okay, very good. Okay, now ini we look back into the questions. Kita sekarang ni you faham because this is line to line refer balik pada nota, you kena clear line to line, cerita dia ialah you nak dapatkan nilai positive sequence current IA1 by using this formula. EA is what? 1 per unit. So we need to know Z1, Z2 and ZF. This is the Thevenin circuit for Thevenin impedance for positive sequence. This one for what? So jawab ni. Z2 for?
Negative.
Very good. ZF for? Pot tapi not be given. Tak ada Okay, tak perlulah. So you kena tahu positive and negative. So from this calculation, you kena simplify the equivalent circuit, this one into Z Thevenin Yang nilai dia. The last one you dapat nilai Z Thevenin which is equivalent to 0.331. So ingat positive circuit, positive sequence and negative sequence dia nilai yang sama for the Z Thevenin. That's why kat sini equation is a positive negative sequence equivalent to positive sequence. Pakai nilai yang sama 0.331 I. So from this formula you dapatlah the value of positive sequence current and then you just substitute into this general formula. So you dapat nilai fault current Okay, fault current dia nilai dia. Okay. So this is the positive sequence, this is the fault current. So this is the sequence network. So for this question. Okay, sampai sini faham? Sampai last sekali. Faham Betul ni? Rasa you nampak tak apa yang cerita ni? Apa yang I explain about? Boleh ke? Guys, ramai-ramai ni?
Boleh sir.
Boleh Syah.
I think I 2 kali dah explain. I think you dapat yang mula-mula mungkin you agak blur. Tapi when it come to the second explanation, I think nampak. Okay. Now, kalau this is the question about line to line. I akan buat soalan sebagai soalan tutorial. I akan minta you buat for not the line to line but single line to ground. This is not the line to line but single line to ground. So when you have single line to ground, the issue is what? Kita back to the nota the first single line to ground. Okay. Alright. Single line to ground dia akan ada short dengan ground. So kat sini dia akan wujud zero sequence ataupun Z0. So you kena consider the Z0. Okay. You have to use this formula. So you need to know the Thevenin circuit for positive sequence, Thevenin for positive sequence. From the sequence you dapat Z1. And then Z1 is equivalent to Z2. Okay. So tak ada masalah. The issue is how to get the Z0 ataupun zero sequence impedance Thevenin. So you kena simplify the circuit. Alright. But the formula yang inilah. Okay. Yang ini. So ingat the fault current equivalent to ni dibagi fault current is 3 times IA1 positive sequence. Okay. 3 times. Maksudnya kalau dapat nilai ni apa benda keluar ni? Salah. Okay. Okay. Okay, cerita dia, you have to obtain the value of IA1 first, positive sequence for current EA is 1 per unit, divide by the Thevenin impedance for zero sequence, positive sequence and negative sequence. This one tak diberi kosong. Kalau dalam soalan diberi, you kena pakai lah. Okay. So, you dapat nilai ni, you have to time multiple by 3. Kenapa 3? Because the fault current, that's the formula for fault current, single line to ground. Formula fault current for line to line, lain. Ini single, ini equation dia. So, jangan silap, jangan salah kira. Okay. Alright. So, macam mana nak draw the equivalent circuit for zero sequence. Okay. You ingat lagi tak the first I explain pasal connection of transformer yang ni semua ni kan? Tengok this one. Okay, bukan okay, sekejap. Okay, this one semua ni Basically this is representing the connection of transformers. So kita boleh guna implement this connection into the circuit. Okay. dalam kat sini, in this tutorial, dia ada dah bagi you zero sequence. Okay. So zero sequence, kita balik pada yang ini. This is positive sequence. So guna sequence circuit ni to determine the Z1 and Z2. But not for Z0 because circuit ni ialah delete lah ni. Macam ni kot. Delete. Okay, circuit ni guna dia untuk determine the equivalent circuit for Z0. Alright. So konsep yang sama from here. Okay, mula you cari positive sequence. Tapi di circuit you kena tukar kepada negative sequence. Okay, macam mana nak tukar kepada zero sequence. Alright, ingat sebenarnya zero sequence ni dia refer kepada ground current Okay, kita tengok yang ini. For example, kita tengok yang the first one Kenapa kat sini? Ini kalau I zoom in. Okay, bila I zoom in ni, you boleh nampak kat sini. You can see here ZG is open betul tak? Dia open ni, dia tak connected dengan T3. Betul? ZG1 dia open and not connected with T1, betul kan? However, G2 and T2 dia connected, dia bersambung Nampak kan? Okay. So why this G3 not connected with T3? Kita tengok pada where is the location for G3 and T3. Okay. G3 and T3. Okay, kat sini So G3 and T3, you tengok this is star connection. Dia ada ground kan? Dia ada ground Ini delta, dia tak ada ground betul. That's why dia open. Maksudnya yang ini bukan dia tak bersambung, physically dia connected, tapi for the I0 ataupun zero sequence current dia tak flow from G3 to T3 because dia pakai star. Okay? So that's why in this case you just open the circuit. Kalau dia positive sequence just open because dia tak bersambung that's why dia tak bersambung. Dia open. However for T3, alright, T3 ni dia ada star kan? And then dia ada ground kan? Maksudnya dia sambung pada reference bus. That's why kat sini dia bypass G3 dan dia connected to the reference bus. Boleh faham Okay. And then look at the G1 and T1. Sama juga konsep dia G1. So G1 dia ada star kan? Dia bersambung pada reference bus. Dia ada sambungan. Yes Dia ada sambungan pada reference bus. Not this one, this is positive. So tapi because of G1 to transformer, dia ada delta. So dia tak ada grounded tak ada So dia open. One more time dia open untuk di circuit. So dia open. Dia tak connected directly pada T1. However, T1 has a star connection with grounded. Dan ini, so dia akan bersambung pada reference bus. So that's why dia bypass the G1. Okay. Okay, tengok pada ini pula. Look at this G2 and T1. Why dia connected? Kenapa dia bersambung Okay, where is the G2? G2, okay kat sini So G2 dia ada Y connection. So dia bersambung. And then between G2 and T2 dia ada star dan dia ada ground. So maksudnya zero sequence current can flow between T2 and G2. So dia connected, dia bersambung. Okay. T2 pada ni dia ada star lah. So dia bersambung lah. So at the end you can get this circuit So G2 and T2 dia join. And then they both join at the reference bus. Okay, boleh faham? Yang lain macam mana? Yang lain tu sama saja, tak ada beza Yang lain tu ini tak ada apalah. Okay. So this is the zero sequence equivalent circuit. Okay. Daripada circuit ni, ini nanti saya buat tutorial saya cakap sekali lagi. So you need to find the value of Z0. So maksudnya kat mana? Kalau tengok circuit ni, so we can eliminate. Ini dah tak perlu masuk dalam calculation. This one tak perlu masuk. So yang existing is only this one. Line ni kan? Line ni, this one and this one. Dia agak simple lah. You tak perlu include G3 and G1 because the open circuit. So during the calculation for zero sequence current, you need only consider this parallel line 1, 2, 3 and this one 4. So boleh faham ke? Okay, boleh nampak tak kat situ? How to determine the equivalent circuit for zero sequence from this circuit? Boleh? Dah ini pun dah ada pun jawapan dia. I nak cuma you faham lah kenapa dia open, kenapa dia close. Boleh faham Ada soalan nak tanya? Kalau tak ada, kita boleh pergi pada topic is protection. Okay. Siapa nak tanya, I buka session for the Q&A session. Ramai-ramai ni, kan semua faham, hebatlah. Okay.
Setakat ni okey je.
Setakat okey
Okey.
I pelik you all, masa kelas faham semua kan, masa test you tengoklah kawan. Okay, that's why you kena biasakan buat exercise. Nampak senang I explain, okay, gitu. Tapi kalau you tak buat sendiri, you tak buat exercise, you takkan dapat apa yang I cerita. You tak boleh nak buat lah. You masa you buat exercise tu, you akan nampak, betul ke? Salah ke? That's why you kena biasakan. Poster 1, kalau you nak betul-betul, you kena biasakan. Okay? Alright. Okay. So now, ada lagi tak siapa-siapa nak tanya pasal circuit ni? Saya, yelah, kalau you salah sketch the circuit ni, you akan silap for the whole calculation you salah. So be careful. Jangan salah. Okay. So ingat ini dia bentuk delta. You kena transform lah kepada star. Itu you dah belajar sebelum ni you cakap. So I think should be okay. Alright. Okay guys. Kita pergi pada new topic on protection. Basically, this is our last topic on power system 1. It's a very interesting topic sebenarnya. Okay. Right, ni Dr. Zul tak apalah. Okay. When fault occurs, what is the protection? You tahu, nama pun you tahu, protection. You nak protect you punya equipment daripada power system network tu. You try to protect our equipment using apa dia. So that's the protection. Okay, when fault occur, fault ni tak kisahlah. Kalau you cakap pasal balance fault, symmetrical, asymmetrical fault occurs. Alright, excessive current will flow in the power system. Why excessive power? Because dia dah short circuit. Bila current dia bypass the load, VIR kan, I V over R. R tu kalau masa fault atau short circuit, R can be R tu, tu load lah, can be infinity, can be zero, can be infinity lah kita kata. So current sangat tinggi. So that's why dikata excessive current will flow in the power system. So the excessive current is very harmful, very dangerous for the equipment in power system. Tak boleh. It's not only for the equipment, untuk human, untuk anything that near to the fault location, dia akan dangerous lah. Okay. This fault current can be several orders of magnitude larger than normal operating currents. If not removed quickly, they may cause insulation damage. Ini kalau kabel boleh terbakar, kabel boleh meletup. Conductor melting, yes, because current sangat tinggi, it can melt the conductor. Copper dalam kabel tu dia boleh melting, dia boleh cair. Mechanical damage to winding and bus bar, and fire and explosion. This is the worst case. Mungkin boleh berlaku kebakaran, fire and explosion. Okay. What happened? Tiba-tiba dia jadi macam ni. Okay. Okay guys. Okay. It's therefore important to have power system protection in order to what? In order to remove the faulted equipment from the system. Mungkin I boleh zoomkan besar sikit skrin ni. Okay. Maintain the unfault system in order to control. Okay, bila berlaku fault, cerita sekarang two things that we need to do. We need to remove the faulted equipment. Maksudnya kalau yang berlaku fault, kita nak isolate, kita nak asingkan. Kita tak nak dia effect others operation. Okay, kalau fault kat situ, kita nak just isolate that part. Yang lain tu boleh operate macam biasa. Itu maksudnya. Maintain the unfaulted system in order to continue service. Okay, protection system have three basic components. Instrument transformers, relay, circuit breaker. These are the basic components of protection. We have instrument transformer, relay, circuit breaker. You tahu circuit breaker kan? Kat rumah pada circuit breaker tak dalam... Mesti ada kan circuit breaker? Ada kan?
Ada je.
Yang NCB semua tu kan, bila berlaku fault ke short circuit kat rumah you, dia akan trip. Betul? Dia akan trip lah, tiba-tiba you punya electricity gone. Tak ada because dia trip, dia nak isolate you punya fault. Kalau tak, what happen? Kalau tak ada berlaku tripping whatever, dia akan damage your equipment, TV, whatever, lighting semua akan terbakar, damage. Okay. Dia satu cara lah nak cerita. Kalau tiba-tiba rumah you tu trip maksudnya bukan trip daripada luar, daripada TMB, daripada dalam entire your house. Tiba-tiba dia trip. So apa you kena buat untuk detect equipment. Sebab dia macam ni, bila trip tu mungkin ada equipment ni tak kisahlah, mungkin you punya TV, you punya fridge, you punya iron, you punya apa lagi, kipas, rice cooker, mungkin ada dah short circuit dalam device tu lah. Okay, so apa you kena buat sebagai electrical engineer? You kena tahu kan, tiba-tiba main trip, so apa you kena buat? Siapa ada idea?
Tutup semua plug switch.
Okay, then lepas itu apa you buat?
Buka satu-satu.
Good Okay, betul. Sebab kita tak tahu dalam rumah tu ada banyak equipment kan. Right? Bila tiba trip, so apa you kena buat? You kena, kalau boleh you cabut plug, cabut semua equipment yang ada dalam device dalam rumah you tu. Okay, tapi kalau lampu tak boleh lah. Lampu tu you off lah, jangan on lah, kan ada switch kan. Okay, and then you cuba onkan breaker tu, onkan semua. Okay, maksudnya bila you on tu, bila you off, dia takkan trip lah, dia on lah kan. Betul? Okay, and then you on satu-satu. You on satu lah. And then bila sampai device yang problem tu, dia akan trip. So you tahulah sama ada rice cooker you ke, kipas ke, apa yang lampu ke, ada short circuit. So you boleh isolate that part. Faham So jangan pula kalau you belajar electrical tiba-tiba trip, you tak tahu nak buat apa. Blur lah. Mak you tanya, I don't know nak buat macam ni. Tak tahu. Kalau luar datang. Itu you boleh buat Tapi kalau you tahu, you ada expertise nak repair tu boleh lah. Tapi kalau you nak trace, maksudnya yelah before takkanlah you nak biar rumah you bergelap, betul? You kena tahulah. You faham tak? You faham kan cerita ni? Boleh buat Kalau in case berlaku lah kat rumah you, itu normal lah, kata apa yang kita buat kita offkan semua, kita on one by one in order to know which device yang problem. Okay? So itu one type of protection. So kita dah tak pakai dah contoh rice cooker yang trip, menyebabkan trip satu rumah. So you dah isolate, you dah buka. Itu is the concept of protection. So sama juga dalam power system network. We need to isolate the part, the area yang ada fault, yang ada faulty lah, yang ada short circuit. Kita tak nak dia effect other operation. Sebab dalam power system network, you tahu kan, dia ada banyak buses, dia ada banyak network, ring bus, whatever, dia banyak. Mungkin ada 100 of buses, 50 buses. Semua orang nak operate. Kalau satu tak clear fault dan tak di-clear wiper, everybody akan affect. So we don't want that happen. That's why we need to isolate the faulty part, faulty area. Okay. So protection system have three basic components. Saya cakap tadi, again, instrument transformer. Basically, instrument transformer ni kita boleh katakan sebagai current transformer and voltage transformer. Apa bentuk current transformer, voltage transformer? So kita juga ada, we have overcurrent relay, directional relay dan impedance relay. And so banyak type. Tapi yang ada common one is current transformer and voltage transformer. Nama apa transformer? Maksudnya dia nak step down the current into specific, into the small amount of current. Voltage pun sama. Voltage pun maksudnya dia nak step down the voltage. Okay, saya nak buka pasal sekejap ya. Mana nak buka ni? Okay. Google Meet. Okay, saya stop sekejap. Okay. Wait a minute. I need to open something to show you. Current transformer, current transformer. Okay. Alright. Let's see. Can we share? Alright. Okay, kita nampak skrin Okay, this is the current transformer. Mungkin kalau siapa-siapa yang tak pernah tengok, this is physical structures of current transformer. Okay, dia bentuk dia macam ni lah, dia bentuk ring ada bentuk ring, tapi basically dia macam ni lah, nanti dia akan dalam ring, dalam hole ni, cable akan lalu lah. So dia akan step down ke the current Okay, sahabat tuan tengok macam ni Alright. Macam ni bentuk dia. Okay. Okay, you kan tahulah physically macam mana bentuk dia. Satu lagi voltage transformer cari voltage transformer. So this is voltage transformer. Okay. Ini voltage transformer. Okay, you tengok dekat incoming PPU ke, banyak voltage transformer untuk protection sebenarnya. Okay, macam ni bentuk dia. Okay. Right. So macam ni lah. Dia nak step down the voltage. Sebab you nak turn on and off relay, you tak boleh guna the actual fault voltage. You can step down kan. Okay. So that's the current transformer and voltage transformer. So satu lagi dia combination, dia ada relay. So ini function dia macam sensor lah, kita katakan. You nak sense the fault current and fault voltage. And then sensor tu dia akan bersama pada relays. Dia ada type of relay, contoh overcurrent relays, directional relays, impedance relay and differential relay. So banyak, kita akan go one by one type of relay. Okay, boleh faham Okay. So system protection components macam cakap tadi. So we have current transformer. Okay. Transformer ni dia akan sense the fault current. Ini contoh current flow. Ini ialah primary current, secondary current. Okay, dia akan sense the fault current. So current transformer ni function dia akan join, dia akan connected dengan relay. Ini relay coil. Kalau you siapa tahu pasal relay. Bila relay coil ni on, contact dia akan on. Dia akan close. Bila close, what happen? Ini ada circuit for to turn on the breaker. Kalau dia close ni current boleh flow. Bila current boleh flow, apa jadi? Breaker ni akan on. Bila breaker on, breaker coil dia akan turn on, dia akan open. Breaker dia akan contact, dia akan open. Maksudnya current ni tak akan, fault current kat sini tak akan flow to the load. Itu konsep dia. Faham So we have current transformer together with overcurrent relay. So current transformer ni again dia sense the fault current. Dia akan step down kepada secondary current, which is value lagi rendah lah. Kalau contoh kat sini mungkin 100 ampere, fault current tinggi 1000 ampere, dia akan step down kepada 10 ampere contohnya untuk operation of overcurrent relay. So when the current this current flow through the overcurrent relay, dia ada specific current untuk turn on the coil ni, dia dipanggil pick up current Bila dia turn on saja, contact dia akan open. Close. Bila close, current daripada bateri ni akan boleh flow and dia akan tripkan, dia akan onkan coil ni. Bila coil ni kat sini ada contact, so ini akan open. So at the end, fault current ni dia kat sini ada load lah biasa. This is the load side So what happen is fault current cannot go to the load side. So we can protect our load because of this breaker open. Okay. Apa maksud open close? Kalau close ni current boleh flow lah. Kalau open, dia akan open circuit. Jadi dia current tak boleh flow, dia open. Okay. Boleh faham konsep dia? So we have the combination of current transformer and relay, overcurrent relay. So relay kat sini, we have many type of relays. Ni dia. Kat sini contoh dia lah overcurrent relay, OC. Kita juga ada directional relay, D. Impedance relay. So semua dia kat sini. So mungkin current transformer ni akan join dengan directional relay. Mungkin transformer ini akan integrated with impedance relay. So tu pula what type of protection yang diguna untuk the system. But the basic dia sama saja. Current transformer sense the fault current, then it will trigger the relay to operate in order to open the breaker to isolate the fault current from flow to the load, to protect the load. Okay, itu dia konsep dia. Alright. The function of current transformer, okay, so I ada cerita in general, so kat sini dia ada sikit little bit of explanation. To reproduce secondary current which will activate the relay. So itulah, okay, transformer ni dia akan produce the secondary current, I prime is secondary, in order to activate the relay. Okay. It converts that down primary current in kilo amp range to secondary current, I prime, into the 0 to 5 amp range. So daripada kilo amp kepada 5 ampere. So you nampak dia step down for convenience of measurement. Okay, so biasanya secondary current ni sangat small lah compared to the fault current. Let's say ini kilo amp, ini only 5 ampere. Dia step down untuk operation of overcurrent relay. Okay, by having low magnitude of current, safety. Kenapa? Provide electrical installation from the power system so that personal working with relay will work in safe environment. Betul lah, kalau you pakai current yang sama value with the fault current kat sini, primary, secondary, so what happen, it will dangerous, harmful for the people who work for the maintenance. Economy, lower input enable relay to be smaller, simple and less expensive. Economic type. Accuracy, accurate reproduce power system and voltage wide operating range. So this is the current transformer. So how about the voltage transformer? Konsep yang sama, cuma kat sini pakai voltage. Okay, ini kita measure the current. We can also measure the voltage fault voltage as well. Terpulang tapi if you want to measure the current, kita akan guna current transformer. If you want to measure the voltage, we will use the voltage transformer. Okay. The function of a relay, so boleh baca kat sini, to discriminate the differentiate between normal operation and fault condition, receive signal or current from a secondary winding of the current transformer. So this is function of a current relay. Part mana? This one. And tadi pasal current transformer, this is the overcurrent relay. So function dia, this one to differentiate between the normal current and fault current. So you tahulah. So maksudnya kat relay ni dia tak akan operate. It won't operate if it's not the fault current. Dia cuma operate if fault current exists. So fault current ni 100 kilo amp besar compared to the normal current. Normal current mungkin rendah lah, 100 amp, 300 amp. Tapi when it comes to the fault current, it can goes up to 1000 ampere. So overcurrent relay only operate for the fault current. Dia boleh differentiate. It can recognize the fault current. Okay. Has an operating coil which is connected to the CT secondary winding. So this one, dia ada operating coil. This one connected the CT. Alright. When I prime exceed the specific pickup IP. So for the OC of relay ni dia ada pickup current. Pickup current ni maksudnya the minimum current that will turn on the coil of overcurrent. Maksudnya minimum value of current to turn on the overcurrent relay. So dia tu maksudnya pickup current IP. So you faham lah kalau you baca, kalau I tak explain mungkin tak faham. So IP is the pickup. So I secondary, I prime must be greater than IP. Barulah dia turn on. This is how overcurrent relay recognize the fault current. So condition dia, I prime must be greater than IP. Secondary current must be greater than pickup current of OC. Okay. When the relay contact close, the breaker trip coil is energized, which when the cause the circuit breaker to open. So concept cakap tadi lah. When the coil turn on, dia akan close the contact. Bila close the contact, current from battery can flow to the breaker coil. Dia akan turn on breaker coil. Bila breaker coil turn on, contact dia akan open dan dia akan isolate the fault current. Okay, itu konsep. The function of circuit breaker, okay, we have circuit breaker to separate between the faulty and non-faulty part in power system. Okay, this is let's say faulty part, this side is non-faulty. So breaker function to isolate, untuk asingkan, isolate, right? It open when there is a fault happen. So dia akan open. Tak open problem. Macam case tadi lah. Kalau you kat rumah cakap tadi, you manually open. We close dan you buat manually. Tapi ada juga dalam protection ni kita ada manual trick yang untuk let's say mungkin ada maintenance engineer yang ada standby, tiba-tiba dia ada fault tapi current transformer problem, tak working, so what happen, dia kena manual trick, boleh juga. So this is two way how to control, how to do the protection in the power system network. Okay. Alright. System protection component, instrument transformer. So this is the in general conclusion of protection components. We have current transformer and voltage transformer to be sent to relay to sense the fault current and voltage, and this one will connected to the relay. So relay we have tadilah OC, definitely itu type of relay ini. Okay, This one okay, case dia macam ni. Okay, identify when fault happen. If yes, it tell the circuit breaker to open. Circuit breaker function dia, its contact remain closed if no fault happens. When fault happen, its contact open and separate the faulted zone from the remaining system. So I rasa dah jelas betul-betul je lah, you bagi faham okay, saya faham dah pasal tu. Okay, okay, kat sini explanation about instrument transformer. There are two basic type of instrument transformer. Voltage transformer, formerly called potential transformer (PT), current transformer. Ya, samalah. The VT reduce the primary voltage and CT reduce the primary current to much lower standardized level suitable for operation of relay. So again, voltage transformer dia nak reduce step down the voltage faults to the lower value lah untuk measurement untuk operation of protection devices. Okay, kat sini in general, step down primary voltage to secondary V to V prime, step down primary current to secondary I to I prime. Okay, so this is samalah konsep dia. Kalau dalam current, kita connection dia macam ni. For the voltage transformer, we put in this way, the VT lah. Okay, current biasa dalam series ini dalam bentuk parallel. Okay, alright. Instrument transformer, voltage transformer, VT is usually modeled as an ideal transformer. The secondary voltage found as V prime 1 over N V, where V prime is the secondary voltage, V is the primary voltage, and N is the VT turn ratio. V prime is the phase with V. Standard, okay, ini standard yang diguna. It's been used in the kata TMB ataupun power system area for the ratio of the voltage transformer. 1 ratio of 1, 2 ratio of 1. Okay. Maksudnya kita boleh choose, we can choose which ratio we want to use, which is suitable for our system. Tengoklah kalau sistem tu voltage besar, tinggi, we guna pakai the higher ratio. Okay. For example, if the primary voltage VT is 200 kilovolt and turn ratio is 300 over 1, the secondary voltage will, so this is, maksudnya kat sini dia step down to the secondary voltage to 0.67 kV from 200 kV. Kat mana? Kat sini lah not this one kat sini 200 kV dia akan step down kepada 0.67 untuk measurement lah, right? Itu konsep saya faham pasal ni. Okay, I explain. Okay, instrument transformer, current transformer, approximate equivalent circuit for CT as shown below. Yang ini Z prime is the secondary leakage impedance, XE the saturable excitation reactance, ZB impedance of terminating device relay, sometimes called as a burden. Okay, ini burden. Ini terminating audio. Okay, tak apa. Ini dia standard of CT ratio, right? So 5M, 3 to 5. Bukanlah dia jadi 5M, tidak, dia ratio, dia standard. Jadi mungkin dia boleh rendah atau tinggi sikit. Okay, the total impedance ZB of the terminating device is called the burden. Okay, associated with the CT equivalent circuit is excitation curve that determine the relationship between secondary voltage E prime and excitation current. Using the CT equivalent circuit excitation curve, the following procedure can be used to determine CT performance. Okay, so ini apa dia sebenarnya? Kalau you baca ni mungkin you tak clear, tapi cerita dia dalam using the current transformer, kita ada curve, kita panggil this is the excitation curve. So kat sini kalau siapa kat sini pernah buat CT setting ke pernah? Siapa ada experience tak? You tak pernah lagi sebab you part 4 sebab you part 4 mungkin you tak pergi lagi pada apa tu intern ke kan, apa tu kita panggil practical kan. Tapi kalau yang pergi tu biasanya part 6, part 7 tu ada student yang dah buat so you nampak lah kat mana nak guna benda ni. Tapi cerita dia in general apa kita nak guna, ini curve sebenarnya. Jadi dia akan ada CT ratio. Tiap curve ni mewakili different CT ratio. Contohnya kalau ini 250 over 5. So ini dia punya curve. This one is 200 over 5. So this is the curve. So based on your CT ratio, you nak guna yang mana. So kita boleh tahu let's say you boleh draw straight line. Contoh kalau kita pakai yang ni lah, the last one So you boleh sketch di sini. So daripada secondary voltage ni, you boleh tahu the value of secondary exciting ampere. Kenapa? Sebab nanti you nak tahu the value of secondary lah. Macam ni lah kita nak tahu secondary current berapa. For example, if the CT ratio is 500 ampere and turn as 900 over 5, yang ini kat sini lah. yang mana sini tak keluar pula 9/5 tapi contoh je 900/5 tak apalah. When the secondary current will assume IE is 0 extension, so we can know the value of I prime ataupun secondary current which is 2.78. So you tahulah, you tahu nilai I prime you secondary current 278, barulah you tahu which overcurrent relay yang sesuai you nak guna, because later on you kena choose the suitable overcurrent relay in order to operate the protection system. Okay, you tahu dah berapa kat sini. So maksudnya you tahu the value of operating coil ni berapa. Sebab later on kita tahu pick up overcurrent kan. Jadi by using this curve, kita akan tahu we can know the value of I prime secondary current in order to determine which overcurrent relay coil suitable to use for this secondary current. Itu cerita dia. So ini biasa kita, kalau you boleh go through lah kalau you minat, kalau you nak tahu kita operate our overcurrent CT dekat curve ni kat sini dah dia panggil saturated region dah, tak boleh guna dah. Sebab dia current transformer dia ada saturated region, tak boleh kita guna area before the knee point. Knee point ni before dia become saturated area ni lah. Okay, alright, so that is very important curve dalam determine the CT ratio and the overcurrent type. Okay, in this chapter there are 4 type of relay to be covered. Okay, sekarang ni we complete the explanation about current transformer. Now we go to the overcurrent relay ataupun protection relay. Ini the second part. Saya balik back to this diagram. Okay, kita dah tahu yang ini. So we need to know this one. Second part is the overcurrent relay. Ini contoh overcurrent relay, not only overcurrent relay, dia ada type of protection relay. Ini contoh. Kita ada many type of relays. Ini pun dia beritahu dia ada how many type of relay kat here. Okay, not this one, this one. Okay, relay. So we have overcurrent relay, directional relay, impedance relay, and differential relay. Ada 4 type of relay yang kita boleh guna untuk buat protection. Of course, each relay it has a different characteristic. Tak sama lain. Okay, ini based on overcurrent. Current tinggi pada pickup dia akan turn on. Directional pun nama pun directional, maksudnya dia operate based on direction of current, forward, reverse. Impedance dia based on the impedance. Differential ni dia tengok the different. Ini kemudian I explain what dia agak complicated sikit nak faham because dia based on differential. Tak apa, we go one by one. Okay, overcurrent relay. Look at the overcurrent relay. Nama overcurrent maksudnya you boleh imagine, overcurrent relay is about it will turn on when the current over the pickup ataupun over the rating of the relay. Okay, overcurrent relay. There are 2 type of overcurrent relays. Instantaneous overcurrent relays and time delay overcurrent relays. Kalau nama instantaneous pun you tahulah, dia terus bila dia dah over the setting of the current, kita panggil pickup current, so dia akan turn on. Nama instantaneous, dia akan automatically turn on, dia akan terus turn on. Kalau ada time delay ni, walaupun dia dah achieve the pickup value, tapi dia ada delay, kita boleh set delay. Sometimes fault ni kita tak nak terus dia turn on, mungkin because of the area, location, position, so kita nak cuba delay kan fault. Ingat bukan senang you nak isolate the part sebab nanti the effect that operation of that particular area, so we have to put a time delay. Okay, look at the instantaneous overcurrent relay. Instantaneous overcurrents relay respond to the magnitude of their input current, I prime, okay, as shown by trip and block region. Okay, if the magnitude of I prime exceed the specific adjustable current magnitude IP, so pickup, dia exceed, maksudnya I prime ni must exceed the value of IP, pickup current, relay contact close instantaneously and to adjust the circuit breaker to trip. Maksudnya it will turn on only when I prime greater than I pickup. Instantaneously. Bila dia sense this condition, dia akan terus and adjust the circuit breaker to trip. Bila circuit breaker turn on, dia akan open. Bila dia open, dia akan isolate the part. Okay. If I prime smaller than IP, then the relay contact remain open, blocking the trip coil. Maksudnya dia tak akan turn on when the I prime is smaller than the IP. Okay, relay. Okay, this is the situation condition. Relay trips when I prime is greater than IP. Circuit broker open. Open ni maksudnya you akan isolate the faulty part. Okay. When I prime is less than IP, relay not trip. Kalau relay contact stay open, circuit breaker remain closed. Bila close ni contact dia close, so current boleh flow through the circuit breaker, so nothing happen. Alright. So this is our relay instantaneous. So apa dia ni? This is the y axis. This is the x axis. Y represented imaginary I prime. R represented imaginary I prime, real I prime. So dia ada bentuk macam ni. Dia ada bentuk circle macam ni. Okay. So because overcurrent ni maksudnya dia mesti above. This is IP. So IP ni small circle kat sini. Faham Maksudnya kita tahu konsep dia when the I prime greater than IP. Maksudnya dia mesti atas lah. Dia mesti greater than the circle. That's why dia warna biru ni kat luar because it representing that the I prime must be greater than IP, dia akan trip. However, if I prime less than IP, which is in this small circle, dia akan dipanggil block region. Dia akan tak turn on. Maksudnya breaker U2 tak open. Breaker U2 remain closed. Trip maksudnya breaker U2 open. Bila kata open, dia akan isolate the part. Current cannot flow to the load ataupun faulty part tu dia isolate. Faham So tengok bagi faham lah kat sini. So trip region when I prime is greater than IP. Block region when I prime is less or smaller than IP. Okay. Alright. Okay, how about time delay? Time delay of a current respond to the magnitude of the input current I prime but with an intentional delay time. Dia ada delay. Okay, the time delay depend on the magnitude of the relay input current. For I prime greater than IP, so maksudnya masa fault, the relay will trip. The time delay of a relay to trip will be small if I prime is large. Otherwise, the time delay will be larger if I prime is small. So concept dia based to the magnitude of the input current I prime. If I prime is less than IP, the relay remain in the blocking position. This relay having two settings: current type setting, the pickup current IIP in amperes; time dial setting, the adjustable amount of time delay. So you faham Bila kata time delay ni, dia base kepada magnitude and kita boleh set berapa lama basically based on the time dial setting. Okay. You tengok kat sini. So this is the kita kena diagram lah for the time delay of a current relay block and trip region. So blocking dekat in the middle within the small circle. Trip here above lah the small. Okay, trip ni dia ada D3, D2 and D1. So D1, T ni dia represent time delay. Time ni masa berapa lama dia nak turn on and turn off. So D1 is the longest time lah. Paling lama lah ni. D2 second, D3 is the shortest. Okay, so dia bergantung kepada I prime magnitude. So makin tinggi ni, makin tinggi the I prime secondary current ni, right? Makin lama it will take kata longer time to trip the breaker to turn on. So kita ada time delay. So how do we set this thing? Based on the kita panggil time dial setting. So ini time dial setting. You nak pakai yang mana? Okay, you nak lambatkan, you can choose from this curve. So dia ada current type setting, dia ada banyak 0.5 until 11. So which time dial setting yang nak guna? Ini ialah untuk type CO8. Dia ada jenis-jenis overcurrent relay. Dia ada type of this overcurrent relay untuk time dial, time delay ni. Ini contoh ialah CO8. Dia ada banyak CO10 macam-macam lah. Tapi ini contoh. Tapi basically dia akan pakai the same concept based on this curve time dial in order to determine the delay. Okay, protection using overcurrent relay. Many radio systems are protected by time delay overcurrent relays. These relays are coordinated fault. The breaker close set to the fault opens while upstream breakers with larger time delay remain closed. So ini cerita dia. For example, we have a radio system, straightforward system macam ni, series system. So apa ni? Ini ialah bus 1, bus 2, bus 3. So B1 is breaker 1, breaker 2, breaker 3. Maksudnya ni, this is the protection device. Kalau you open breaker ni, maksudnya current tak akan flow. So yang lain ni akan selamatlah. Ataupun kalau you open breaker ni, so ini akan isolated from the source. Okay. Contoh, P1, P2, P1 apa? P1, P2, P1 is the fault location. Nanti I explain. So L1, L2, L3 is the load. Load 1, load 2 and load 3. Okay. So P2, P1 is the fault. Okay. Contoh, consider a fault P1 to the right of breaker B3. So where is the fault? Fault, let's say P1 at the right of B3. So let's say berlaku fault kat sini. Ada line to line short circuit. Line to line fault berlaku. So what happen? Dia to the right, B3. Okay. So for this fault, we want breaker B3 to open while B2 and B1 remain closed. So what happen? Kalau fault kat sini, kita nak isolate yang ini je kan, area sini, betul? So tapi yang load 1, load 2 ni kita nak remain intact, remain operate. Kenapa kita tak nak disturb dia punya operation? Ya. Kalau rumah you kat sini, rumah kawan you kat sini, rumah kawan seorang lagi ada fault. Okay, bila berlaku fault apa? You tak naklah rumah you effect atau rumah kawan you effect, you cuma nak effect yang faulty area sahaja. So maksud dia. So for this fault, we want breaker B3 to open. When ini open, apa jadi? Dia akan isolate fault area dengan good area lah, yang not faulty area. Okay, and B2, B1 remain closed. So remain closed. Under this condition, only load 3 is interrupted. Load 3 is interrupted. Bila this open, current tak boleh flow, so dia akan isolate. Only load 3, this load only interrupted. We could select a longer time delay for B2 as backup and B3 operate first. Okay. Kalau untuk project delay, kita boleh set time. Maksudnya kita bagi lambat lah. Dia tak on instantaneously. Kita set delay. Does B3 provide primary protection for any fault to the right of B3? Only B3 fails to open, B2 opens after time delay, thus providing backup protection. Apa maksud dia? Okay. Hamba nak join my room ke? Is it? Okay. Alright, someone join my room. Okay. Okay. So you faham tak apa yang berlaku kat sini? Again, fault at P1. So what happened? We only want the fault. We only want to isolate this load L3. Okay. So kita tak nak L1, L2 affected by the fault. So what happened? We nak this one to trigger first. B3 to open. So B2 and B1 and B2 ni remain close. Maksudnya kalau dia close, current boleh flow, so means that dia tak interrupted. However, let's say B3 you katakan ada problem, it's not turn on. Mungkin ada masalah mechanical, relay problem ke relay device rosak, whatever. So B2, B1 ni dia akan provide secondary protection for B3. In case tiba-tiba lah B3 turn on untuk mungkinlah after 10 minutes ke 5 minutes B2 akan open lah. Itu cerita dia. That's why kita kata protection using overcurrent relay by delay, time delay. So maksudnya it took more operation time. Ini yang the first one, second one longer, and third one the longest kat sini lah, time operating time. Okay, faham Okay, boleh Okay, what happened to the P2? P2 sama juga we want B2 open while B1 remain closed. So bila fault kat sini, kiranya kita nak ini open, tapi L2 akan affected. How about L3? Affected ke tak? You rasa? Kalau kita open B2, apa akan jadi pada L3 and L2? Siapa boleh jawab? Affected tak?
Dia effect.
Effect lah kan? Dia akan effect, confirm akan effect. Because why? Because this is your source. Source current kat sini. Bila di open yang ni, current tak akan flow to the L2 and L3. So dua-dua affected. Tapi fault kat sini. Jadi kalau fault kat sini tak boleh buat apa lah. So only intact, only not interrupted, only L1. So B1 as a backup for B2. Okay. Alright. Okay. Does B2 provide primary protection for fault? Dia kata primary ni the main protection because fault kat sini. Alright. Similarly, B1 provide primary protection for fault between B1 and B2. Okay. So ini pula primary protection untuk sinilah. Yeah. Okay. That is the overcurrent relay. So faham Overcurrent relay or konsep dia it must be higher than the pickup. Itu nama dia overcurrent, over the pickup current Okay, and then dia ada dua type of overcurrent. Satu instantaneous and the other one is time delayed. Okay, now we go to the directional relay. Nama pun directional relay, so you can imagine dia based on the direction. Directional relay. Okay. Overcurrent relay can be also used with the use of directional elements. This type of relay called directional overcurrent relay or simplified directional relay. Okay, directional relay are designed to operate for fault current in only one direction in forward direction. Sebenarnya dia bergantung kepada current flow forward direction. Okay, so nama dia directional relay. Ingat current ni you tahu satu dia positif. Ingat tak ada current ada I kata I nak explain sebelum ni yang current ni dia ada positif and negatif. Magnitude sama tapi what is the positive, what is negative? Sebenarnya ialah direction of current. So kalau untuk directional relay dia operate only for the positive current atau kita katakan forward direction of current. When the current become negative dia takkan operate. So the relay can sense, dia boleh detect sama ada current tu dalam bentuk forward bias ataupun negative bias ataupun kita kata forward direction or negative direction. Okay, with the inclusion of directional capability, the overcurrent relay become directional overcurrent relay. Okay, so this is the diagram for directional relay in series with overcurrent relay. So we can combine satu directional relay, satu overcurrent relay. Kita tahu overcurrent relay ni konsep dia karakteristik it operate based on the magnitude of fault current. Kalau dia higher the pickup, dia akan turn on. Tak kisahlah dia time delay ke instantaneously tapi dia based on the pickup. Minimum pickup Tapi kalau directional current dia based on the direction. Sama ada current positive or current negative. So we can combine these two relays, directional and overcurrent relay in order to do the protection for our system. Okay. So you can see from this circuit, so dia ada circuit 1, 2, 3, phase A, phase B, phase C. So each phases has a CT, current transformer. And then let's say we look at the phase A, current transformer ni connected with the directional relay and overcurrent relay. And dekat sini juga ada voltage transformer. Okay, so kat sini ada breaker. Kat sini ketiga ni ada breaker. Phase A, phase B, phase C dia akan connected dengan breaker. So ceritanya kalau berlaku fault, kita nak turn on the breaker. Maksudnya breaker akan open, fault current tak boleh flow to the load, so dia akan save our load kat sini lah ataupun kita isolate. Okay. Alright. So consider the directional relay in previous figure, which is required to operate only for fault to the right of CT. Okay, cerita dia to the right of CT. Maksudnya kalau berlaku fault kat P1, kita nak fault dia, kita nak isolate the right side only of the current transformer. Okay. Since the line impedance is mostly reactive, a fault at P1 to the right of CT will have fault current I from bus 1 to bus 2 that lags the bus voltage by the angle of 90 degree. This fault current is said to be forward direction. On the other hand, fault at P2 to the left of the CT will have fault current I that lead V almost 90 degrees. This fault current is said to be reverse direction. So dalam kat sini you nampak satu forward direction and reverse direction. So jangan confuse dengan lagging and leading. Itu dalam power factor. Ini lain. Ini ialah untuk directional. Kita kata ada satu forward direction and satu reverse direction. Okay, kat sini. So kalau fault occur kat sini, okay, so kita katakan bahawa current dalam bentuk forward direction. Kenapa forward? Because sebenarnya kat sini akan ada source. Dia ada source kat sini, generator, kat sini ada load. So current akan flow daripada sini, daripada source kepada load kan? Normal operation source kepada load. So dalam normal operation ni kita consider sebagai forward direction. Maksudnya daripada source pada load. Tapi kalau source you kat sini, load you kat sini, current akan terbalik kan? So dia akan jadi reverse direction. Tapi in this case, right, kita consider source kat sini, source this area, generator, and load kat sini. So current akan flow from generator to the load. So means that this current I in the forward direction. So dalam normal current flow. So when fault occur at P1, current transformer akan tengok current dalam bentuk forward direction, dia akan turn on. Tapi kalau dia berlaku dekat P2, P2 ni sebab current transformer ni you sambung kat sini, bukan kat sini. Kalau you letak current transformer kat sini, dia akan jadi forward. Tapi because the current transformer is connected after the P2, bila berlaku fault kat sini, dia akan jadi reverse ataupun reverse direction. Dia tak akan turn on. Okay, ingat direction relay dia operate only for the forward direction. Okay. So because P1 is located here and your connection, our connection is here, which is before the P, so ini kita consider sebagai forward direction. Okay, again, let's say for the P2, fault at P2 because current is connected after the P2, so untuk this condition, kalau berlaku fault, ini akan nampak sebagai reverse direction. Kalau jadi positif macam mana? You letak satu current transformer kat sini and current flow from the generator to the load, so dia akan jadi forward. Dalam case ni, again, I cakap is reverse direction. Okay, forward, kat sini ada explain forward and reverse. Boleh faham forward and reverse? Faham ke? Semua orang ni faham ke senyap?
Kurang sikit.
Faham sikit. Okey, I bagi faham banyak lagi Okay. Sekali lagi sebab you baru dengar about this thing, you baru belajar, okay, you agak you tak nak dapat imagine kan. Okay, satu forward and reverse. Macam mana nak tahu again Macam mana forward and reverse? Okay. Okay, tak apa, kita buat macam ni lah, senang senang je untuk explain. Okay. Saya nak zoomkan Okay, saya buat macam ni. Alamak dia dah. Okay, kat sini Ctrl V. Alright. Okay, kita buat kat sini biasanya akan ada satu generator Betul sambung pada bus, okay? Okay? So ini akan sambung pada bus juga. Contoh ini bersambung lah ni. Okay? Kita sambung dia connected Dia join dengan bus 1 and bus 2. Okay, ini bus 1 and this is bus 2, ini pada load. Your load. Load lah kat sini. So what happen? Fault kat sini. Okay. Ingat current daripada mana? Daripada sini ke sini kan? Current flow sini ke sini kan? Betul
Betul.
Okay. So bila berlaku normal operation, current flow, kita consider sebagai forward lah. Okay. So what happen is ini ialah protection system kita. So this is the fault area. So protection CPU ni you sambung before the fault. Fault kat sini kan? So current flow dari sini kan? Betul. So maksudnya protection device tu before the fault, maksudnya dia akan bentuk forward. Because benda ni, this protection system ni before you punya fault area, fault location. However, for P2 pula, ni P2 kan? Fault kat sini. Tapi you punya setting protection device ni after. So current you ke sini kan? Okay, so maksudnya dia akan nampak reverse because this device located after you punya fault. In order to make it forward, apa you kena buat? You kena letak kat sini. Faham Faham? So current tu, dia apa cerita dia? Dia akan current, kenapa jadi forward? Because current dia akan flow through CT dulu, barulah dia pergi pada fault. Itu jadi forward Kita katakan positif lah. Tapi kalau current tu pergi fault dulu, barulah dia masuk pada CT, dia akan jadi reverse. Negatif. So in order to make it forward, you kena ambil yang ni, you kena letak kat sini. Okay? Faham Boleh faham ke?
So kita memang nak forward lah. Kita tak nak reverse.
Kenapa kita tak nak reverse? Because the operation of directional relay only operate when there is a forward current. Dia nak forward saja. I forward saja dia akan turn on. Faham Ini kan bentuk, ini kan gate ni. Maksudnya in order this one to turn on, dua-dua kena on. Maksudnya ini kena turn on and ini kena turn on, barulah dia akan turn on. Maksudnya kat sini, characteristic of directional relay, we only need the forward current. Kita tak nak reverse current Okay, apa dia soalan?
So breaker tu apa? Akan trip kalau forward je lah.
Okay, breaker ni, okay, you tengok dulu kat sini okay, breaker ni, mana breaker? Ini breaker kan? Breaker ni akan trip. Not only because you ada combination. Ini tengok ni, ini and kan. Maksudnya dua-dua kena on. Ini on baru breaker on. Sebab you pakai dua-dua, you ada combination directional relay dengan overcurrent. Tapi kalau you pakai only directional relay without overcurrent relay, yes. Bila forward current, dia tu akan turn on. Tapi ni tak boleh. Dalam case ni, dia ada combination between directional relay dengan overcurrent. Ingat overcurrent relay ni dia nak turn on based pada apa? Pick up current kan, IP. Betul? So current tu mesti besar pada IP kan, baru dia turn on kan? Current ni. Ataupun primary current kat sini, I prime kan? Ingat explain tadi. So maksudnya kat sini, untuk this diagram, satu, it needs forward current, I forward, then plus the I prime, which is greater than I pick up. Kenapa? Sebab dia bentuk N ni kan? Dua-dua on baru dia akan breaker on. Bila ni on, barulah breaker ni akan on lah. Faham boleh? Ada soalan lagi tak? Faham So you faham pasal forward and reverse? Tahu kan? Okay, tak apa. Nanti you akan jumpa lagi. Ada banyak lagi contoh-contoh. Okay. Okay. Kenapa jadi macam ni? I terpaste kat sini. Okay. Alright. So consider. Okay. So ini ada explain. Okay. Directional relays has two input. Name the secondary voltage of VT and secondary current of CT. Alright. The condition to trip. Okay. So ini dia punya diagram, directional block. So maksudnya dia akan trip dalam region ni. Sebenarnya inilah region forward region. This is the reverse region. Dia tak akan turn on. So ini dia punya angle of current I prime, boundary between trip and block region, typically 2 to 8 degrees. So sama juga konsep dengan overcurrent relay. Dia akan ada trip region and blocking region. So cerita sekarang trip region, current mesti forward direction. Block region is reverse direction. Okay. The torque will cause a directional relay to trip. To close its contact can be calculated as follows. So you kena faham ada calculation in terms of torque kan. Torque maksudnya relay ni sebenarnya dia ada coil. Coil tu dia nak turn on and off, dia perlukan some kind of torque lah untuk gerakkan dia punya contact tu. So itu kita measure dia punya torque kan, kita panggil torque. Torque ni macam force, macam power yang nak boleh turn on and turn off the coil contact tadi. So this is the equation. Alright. Okay. Okay. The forward in the forward direction, the current lag the voltage, the angle, this angle, close to positive degree. This result in maximum positive torque on the rotating disc of relay, which would cause the relay contact to close. For forward in the reverse direction, the current leads the voltage 90 degree. This result maximum negative torque on the rotating disc of relay, which would cause the relay to contact to open. So cerita sekarang ni senang cerita lah. Ini explain kat you. Alright, satu forward, satu reverse. Satu when the forward direction, what happen, dia ada maximum torque, which is it can rotate the disc of relay, which would cause the relay contact to close. Kat mana relay contact? Ini lah relay contact. Dia akan ada torque yang akan close the relay contact. Bila close apa jadi? Current dan dia akan flow. Dia akan trip the coil dan dia akan open the breaker. Okay. Alright. So what happen in forward direction of directional relay? If I let the V 90 degree maximum, relay contact close, directional relay trips. If I lead the voltage minus 90 degree, torque maximum, relay open, directional relay not trip. Okay. Alright. So directional relay, so for protection of system that has both overcurrent relay and directional relay, satu directional, satu overcurrent, the circuit breaker will open if both condition as follows are satisfied. Saya cakap tadi lah, satu overcurrent relay, I prime must be greater than I pick up. Ingat overcurrent relay dia operate based on I pick up. Maksudnya minimum untuk turn on the coil that I pick up. So I secondary must greater than I pick up. Directional relay, the fault happen in forward direction. I lack the voltage. Ini kita kata forward direction. Ataupun dalam ini kita kata I lack the V. Okay. Example, biar dulu. I skip example petang. Tak payah buat lagi later on dah. Okay. Okay, protection of two systems. Sikit lagi mungkin I nak habiskan sampai sampai zone lah sikit. Buat sampai zone, the next week kita akan tengok pada impedance relay. Look at it. Okay. Sikit lagi tak banyak ada pun. Okay. Dah sempat lagi Okay. Protection of two source system with directional relays. It's become difficult and difficult in some cases. Impossible to coordinate overcurrent relay when there are two or more sources at different location. Okay. Yang tadi kita buat straightforward, kita only have one source. Okay, one source. But what happen if you have two source? So dia akan jadi complicated because the determination of forward and reverse tu dia akan jadi complicated. Faham tak? Because you tahu forward and reverse ni dia bergantung pada flow current daripada source kepada load. Now, what happen if you have two sources in one system, one line? Okay, kita tengok one by one. Consider the system with two source as follows, where B12, B21, B23, and B32 are circuit breakers with directional relays, while B1 and B3 are circuit breakers with overcurrent relays. Okay, tengok. B12, this one, this relay. B21, this relay. B23, this relay. And B32, this relay are using directional relay. So bila kata directional relay maksudnya ialah dia operate based on the forward and reverse. Tapi sebenarnya dia only need forward current to operate. And B1, B3 are circuit breakers. So B1, B3 ni not the directional relay but the overcurrent relays. Kalau overcurrent relay dia based pada pickup current. Okay, so macam biasa, we have 3 bus system, 1, 2, 3. So this is P2 fault location at P2, fault location at P1. So load 1, load 2, load 3. So what happen kalau fault berlaku kat sini and what happen if the load occur kat sini. Okay, faham okay, kita tengok kat sini. Suppose there is a fault at P1. Fault berlaku dekat P1. Okay. Alright, the fault happen in forward direction for B23, okay, B23, B32, okay, and B12. We want, okay. Sekejap saya ada call sekejap. Nanti I continue balik. Okay, okay, ambil take file sekejap Okay, dengar ke? Okay, sorry guys. Okay, ada tak semua orang ni?
Ada sir.
Semua ada Okay, I ada kode, sorry. Okay guys, kita sambung sikit lagi. Hi, saya sudah kat mana tadi? Okay, this one Okay. Okay, again mungkin yang sekali you tengok, you look at this slide, 2 or 3 slide later you akan faham Okay, cuba kita tengok one by one case by cases Okay, it be difficult in some cases, impossible to coordinate overcome relay when there are 2 or more sources at different locations. Consider the system with 2 sources as follow. Okay, so we have again jadi B12, B21, B23, B32 are the this breaker it use the directional relay, and this is overcurrent relay, betul Okay. So suppose there is a fault at P1. So ada fault dekat P1. This is P1. So if the fault happen in forward direction for B23, forward B32 and B12. Yang lain tu jadi reverse. Kenapa jadi macam tu? Okay. Fault kat sini. Okay, mungkin I boleh okay, I buat macam nak bagi faham Okay. Right. Itulah kita ambil dulu this one first. Ini ialah dekat tadi So basically ini semua 1 2 2 3 4 ini dia pakai directional relay. Okay, biasanya kita akan letakkan overcurrent relay with, ataupun kita kata directional relay ni dekat sini satu sini. Untuk B12 this area, untuk B21 kat sini Okay, ini setting dia okay kat sini, and B32 kat sini. Okay, so you tahu dia akan ada this mana not this one, ini lah ini Kali ni kita cuma fokus on directional, this ini not exist because dalam question, dalam explanation dia pakai this one So device ni dia letak dekat sini dekat area sini satu untuk B12, B21, B23 and B32. So fault kat sini. Okay. So what happen is sekarang akan flow ke sini dekat sini dia akan stop kat sini So, because ada dua source dekat sini dia akan kat sini kan. Okay. So what happen is ini akan jadi forward, ini jadi because dekat belakang kan, dia akan jadi reverse. Ini akan jadi forward. So B12, B23, this one pula okay, ini tak sebab ini overcurrent dia tak ada forward reverse, so only direction So ini akan jadi forward. So ada B12, B23, B32 are the loop the current in the forward direction Okay. So kan B23, B32 and B12. So B23, B32 and B12 are the condition of forward direction. Boleh faham kenapa jadi forward? Okay. Sebab kes macam ni lah. Right? Because fault dekat sini. Fault here. So current daripada source dia akan lalu all the breakers. Tapi kita ingat relay you put kat sini. Dia letak sini Kita this is the setting untuk protect bus 1, bus 2 Kita letak ni satu, sini satu. Ini breaker, relay kat sini okay. Okay, this one and this one here and this one here. So whatever current akan flow. So whatever is B12 akan jadi forward. Ingat forward. Ini akan jadi reverse. Kenapa reverse? Because equipment you, relay you belakang pada breaker kan, dia jadi reverse. Ini jadi forward dan dia akan stop dekat fault So forward and this one juga sama. B32 is forward. So we have B12, B32 and B23 B23 and B32 as a forward condition for the current Okay. The fault in forward direction for B23, B32 and B12. We want B23 and B32 to clear the fault as they are close to the fault location. So what happen is we want to this yang ini this ni operate first sebab dia fault kat sini. So we want to this one operate first in order to isolate the fault. So kita nak ni dulu. So ini akan jadi primary protection and this one akan jadi secondary ataupun backup protection ya. Alright. B12 could be function as backup by setting its time delay longer than the B23. If B23 fails to open, B12 will replace its roles. B3 could also function as backup if B3 fails to open. So maksudnya kat sini ada dua backup. Satu, kalau current breaker ni tak open, so dia akan ada backup at breaker B12. Tapi setting time delay dia agak lambat lah pada this one. And let's say if B32 tak on, the backup come from B3. Okay, this is the explanation for this one. Okay, kita tengok pada second explanation. What happened? Fault occur at P2. Sekarang ni fault berlaku fault at P2 pula. Okay, kalau you go through these two examples, you boleh faham lah. Okay, again explain sekali lagi. So kat sini you letak you punya overcurrent relay. So this is overcurrent relay. So this is overcurrent relay and this is the location for overcurrent relay. Kat sini tak adalah, sorry, not overcurrent relay, this directional relay. 1, 2, 3, 4. So fault kat sini. Right? So walaupun current akan lalu kat sini, dia source kan, dia akan lalu, dia akan stop kat sini. So yang ni pula sama juga, dia akan lalu all the way and then fault dia akan stop kat sini. So yang mana akan jadi forward? Boleh jawab? Yang mana? Which one will be forward? Okay, yang mana forward? Ni kan? Lagi? Ini jadi forward ke tak?
Forward.
Forward
lah. Jadi forward. Source kat belakang.
Ya. So ini jadi forward tak?
Tu reverse.
No, reverse. Ini?
Forward.
Forward. So we have 1, 2, 3 yang forward condition. So kalau you tengok kat sini pun B12, B21, B23. So B12, B21 and B32 kan? Kan betul lah, B32 kan? Tu tak apa So you faham lah, faham Okay, good you boleh faham Okay, so B12, B21 and B32. So we have B12, B21 and B32. So ini apa dia? Ini jadi reverse sebab kat depan so current go to the breaker dulu baru masuk pada tak boleh dah salah dia dah forward
Sir,
reverse. Ya. Yeah.
Kenapa B32 tu dia forward juga?
Mana? B32. Kenapa? Because current ni okay. Mungkin dah buat conteng nanti tak nampak Okay. Fault kat mana? Fault kat sini kan? Okay, fault kat sini kan? So current daripada sini dia stop kat sini. Tapi ini current daripada sini dia akan go through all the way dan dia akan stop kat sini. Tapi kena ingat location for apa tu direction relay kat sini Ini kat sini, kat depan So maksudnya because current flow dia flow first dia kena flow through the overcurrent relay dulu. Sebab tu jadi forward. Kalau macam ni dia jadi reverse. Kenapa reverse? Because relay you kat sini tapi dia current tu go to the breaker dulu. Faham Jadi reverse.
Okay, faham.
So this is reverse. Tu nak valid tak boleh because ini valid. Ini pun sama valid and this one valid Tapi valid bukan untuk this current tapi current yang ni, source yang ni. Faham Okay, boleh Okay.
Boleh.
Alright, good. So then we have also the backup. Cerita backup sekarang ni kalau fault kat sini dia ada backup lah, means that B32 could function as a backup. Where is B32? This one Kita nak kenapa backup? Because dia located far. B32 ni located far from P2 kan. Jadi kita nak primary protection yang mana kita nak yang ni lah dulu. Betul tak? So this is primary. Ini dulu turn on. Let's say kalau this one not turn on, ada damage whatever, ini akan jadi backup. Sebab dia still dalam bentuk forward direction. Faham Boleh Okay. Inilah backup. Ini tak boleh sebab dia reverse. Tak valid. So ada dua lah kat sini untuk source ni. Satu yang this one, second one this one. So this is the backup. Ini pun boleh jadi backup juga, tak ada masalah. Alright. Kalau untuk case ni, kalau this one fail to open, ini akan backup dia. B1. Okay. So B1 could also function as backup if B2 fails to open. So boleh nampak ke? Semua faham
Boleh sir.
Alhamdulillah. Okay, you faham good. Okay, protection using national relay bus faults. Okay, sama juga. If the fault happen at bus 1. Okay, ini condition lain pula. Saya open sikit. Konsep yang sama sebenarnya. Screen. Okay. Alright. Okay. If fault happens at bus 1. So ni bus 1. Okay, fault also ada dekat bus 2. And the other one is bus 3. So these are the condition. So B1, B1 to operate. Okay. Bila fault kat sini kadang macam ni lah. Kan? Kadang macam ni Betul So fault kat sini dia akan stop kat sini So bus 1, B1 and B21 we operate to clear the fault. B1 and then B21. So ini jadi reverse kan sebab dia dekat depan Betul. So ini jadi forward lah sebab dekat sini kan. Nampak ke? Saya tak lukis lah dia punya relay Betul So B1 and B21 operate to clear the fault. Yang lain tu boleh backup lah. So ini menjadi backup. Ini jadi reverse, not valid. So yang valid only B32, B21. This one is B1. How about this one? This one ni dia jadi reverse kan? Betul tak? Sebab dia cover di sini kan? Fault kat sini kan? So dia tak valid Faham So B1, B21 will operate to clear the fault. So B1 and B21. Boleh nampak ke? Sama lah kan? Ini faham tak ni? Yang ni faham
Boleh.
Konsep yang sama, nak ulang yang sama. You kena tahu flow of fault current lah. Kalau ini pula bus 2 kat sini. So current akan jadi macam ni. Stop kat sini. Ia akan stop kat sini. Okay. So yang mana jadi forward you rasa? Ini forward kan? Ini forward reverse. Forward reverse. Reverse. Yang ni pula forward kan? Ini forward reverse. Reverse lah sebab dekat sini depan ni kan. So yang mana backup protection inilah. Sorry, primary kita nak this one B12 dengan B23. So B12, B23 nampak to clear the fault. Backup mungkin ada pada sini ataupun daripada sini backup. Sebab yang lain tu tak valid Okay. So sama juga kalau implement at bus number 3. The same thing. So fault kat sini, current akan flow ikut sini, dia akan stop kat sini. Yang ini akan flow, ini akan stop kat sini. So ini akan jadi, ini kena turn on lah kalau dia fault. The only one. Tapi ini akan jadi, no valid lah, reverse kan. Reverse, ini jadi forward, ini jadi reverse, tak valid kan. So ini jadi forward. So ada tiga relay So ada 3, 1, 2, 3, 4. So primary protection, kita katakan yang ini dengan yang ini. Backup, so it can be B12 or B1. Backup ni apa? Backup ni kalau let's say this one tak operate ini tak ada cakap apalah kalau ini tak on tiba-tiba dia ada fault mechanical problem, so ini akan turn on, tapi you kena set masa lah, time delay. Okay, alright. Okay guys, so nak habis masa sikit lagi. So zone of protection, saya sikit lagi lah zone protection ni. Okay, tak banyak apa, zone protection ni based on zone. Okay. Fundamental concept in protection is the division of system into protect. Ada juga zone kita ada relay, kita base pada zone. Zone ni, you tahu kan zone, kita tengok sini zone kita letak zone. Contohnya transformer satu zone. Generator satu zone. Between the transformer satu zone. Okay, this is zone of protection. Okay, itulah masuk zone. Zone protect, okay. If a fault occur anywhere within the zone, the action will be taken to isolate that zone from the rest of the system. Kalau berlaku fault kat sini, semua akan turn off. Cut off. Semua akan off semua. Breaker semua turn on. Itu maksud dia. Kalau guna zone of protection. Okay. Okay. Division of protection zone can be performed using 3 steps as follows. Step 1, define the zone of a line components such as transmission line, transformer from the bus bar. Bus to another bus, each zone will have 2 breakers. Define the zone for bus. Any breaker connected to the bus are in the same zone. Define the zone for terminal components such as generator, motors and loads. So cerita dia, you kena define, you kena tahu. So biasanya kita ada standard lah. Okay, untuk generator satu zone, transformer satu zone dan dia akan ada overlap. Untuk bus bar satu zone, transmission pun zone, letak zone for line, zone for bus, zone for transformer, zone for motor. These are the zone of protection. Okay. Okay, protected zone have following characteristic. Zone are overlap. Yes, zone are overlap. Setiap zone dia akan overlap. Okay, circuit breaker are located in the overlap region. Circuit breaker mesti ada dalam overlap region. Jangan terkeluar sebab kita nak turn on and off the fault. Okay. Then the fault happen in a zone. All circuit breaker in that zone open to clear the fault. Kalau berlaku dekat mana-mana sini, contoh berlaku kat P1, semua breaker dekat sini, breaker sini akan open. Dia terus directly dia akan open, dia akan isolate. Okay. Alright. Okay, neighboring zone are overlap in order to avoid the possibility unprotected. Kadang-kadang kenapa ada overlap? Because kita tak nak ada area yang tak di cover ataupun tak not be protected. You kena faham power system network ni satu sistem yang besar. You tengok ini memanglah small scale of network. Tapi kalau tengok dalam sistem grid Malaysia pun dia ada many hundreds of buses. Kalau area Shah Alam tu berapa bus, berapa dia punya load bus system. Dia sangat complicated. That's why kita pakai zone. Mesti ada overlapping zone untuk cover all the region, all the areas. Okay, without overlap, the small area between the two neighboring zone would not be located in any zone, thus would not be touched. It's very dangerous kalau tak ada protection. So it must be overlapping between the zones. Okay, you nampak sini overlapping. Contoh zone 7, zone 8 ada overlapping, 8 to 9 dia ada overlap. Okay, from the previous power system, zone for terminal component, zone 1 to 139, zone for bus 47. So terminal component 139. So kat sini terminal 1, 3, 9. Terminal ni yang hujung lah. Okay. Zone for bus 4 and 7. 4 and 7 bus. Zone for line component 2, 5, 6, 8 and 10. Dia tengok kat situ. If a fault occur at P1, then the two breakers in zone 5 should open. Contoh kalau berlaku fault kat sini, breaker dalam zone 5 ni dia akan open. Okay. If fault occur P2 within the overlap region, zone 4 and 5, then all 5 breaker in zone 4 and 5 open. So contoh kalau ini overlap region between zone 4 and zone 5, occur kat sini. Okay. So semua yang overlap tu akan turn on dia akan breaker turn on Okay, dia kata kat sini. Okay, not this one, not this one. Okay, if for IOP2, the zone 4 and 5, then all 5 breaker in zone 4 and 5 should open. 4 and 5 dia akan open semua. 1, 2, 3, 4, 5 So kalau ikutkan zone 5 and 4 ni dia overlap kan? Fault kat sini. So between zone 4 and 5 there are 5 breaker. 1, 2, 3, 4, 5. So all the 5 breaker dia akan open. Dia akan trip to isolate the fault if fault occur at the overlap region. Kalau yang ni saja, ini sajalah, this one and this one. Okay, clearly if fault occur within the overlap region, two zones will be isolated and larger part of system will be lost from the service. To minimize this possibility, overlap region are kept small as possible. So logiknya you tak boleh besarkan overlapping zone sebab nanti contoh kalau berlaku fault kat sini, you terpaksa turn on all the breaker ni semua. Jadi dia akan effect banyak lah. We try to minimize the overlapping zone. Tu biasalah design dekat protection designer, dia akan cuba minimize the overlapping zone. Okay. So ada example. Okay. Take one example because nanti I akan go to the impedance relay. Sikit lagi soalan pun 65 sikit lagi. Draw the protected zone for the power shown below which circuit breaker should open at port P1 and P2. So dia bagi macam ni, you will refer pada nota. So this is the protection zone. Okay, fault at P1. Where is P1? P1 kat sini. Breaker 2, 4, 4, 2 will open. Dia bukan dekat overlap kan, bukan kan kat luar kan. So breaker 2, 4 and 4, 2 open. Sebab dia dalam zone 5. Fault at P2. Where is P2? Mana P2? P1. I cannot find P2. This one P2 semua. Okay. So P2 ni dekat overlap kan? Betul So when overlap between zone 4 and zone 5. Betul? So maksud apa cerita? So dia akan all breakers within the area of zone 4 and zone 5 dia akan on lah. Akan trip So B21, B23, B24, B42 1, 2, 3, 2, 4 and 4. So faham Okay. Zone of protection. Macam mana nak draw? Biasa kita draw macam ni lah. Untuk terminal, untuk zone, untuk line. And then bila you draw dia, you akan nampak overlapping. You akan jumpa overlapping juga. Okay. Okay, kita stop kat sini. So ada soalan? Dah pukul 5 dah pun. Any question you nak tanya Ada Semua okay
Okay, sir.
Okay, very good. Semua okay. So kita stop our class session at here. So I hope to see you again on next week. So I akan masukkan soalan tutorial untuk you buat untuk symmetrical fault. Okay, kita cuba buat symmetrical fault. Sorry, unsymmetrical fault. Symmetrical kita dah buat tu. Itu saja. Thank you very much dan okay, that's all. Happy weekend semua. Assalamualaikum. Terima kasih. Ada apa-apa tanya? Tak ada?
Tiada, sir.
Okay, bye. Thank you very much.
Salam. Thank you, sir.
Terima kasih, sir.
Alright.
Thank you, sir.
Thank you, sir.